Assalamualaikum and hi, sorry you have to hear my voice again. So for this lecture, I will continue with the lecture 3 of 4, which is focusing on subtopic 4.3 to find the inverse matrices. Okay, so there are three methods to obtain the inverse of a matrix. The first one is by using the adjoint method. So the formula for adjoint method is A inverse is equal to 1 over determinant of A multiplied with adjoint of A. And then the second method is to use the properties of A multiplied by B is equal to K of identity. And then the last one is to use the elementary row operation, or the short form is ERO, where we will discuss this in tutorial. Okay. So for today, the learning outcome for the first part is at the end of the lesson, students should be able to compute the inverse of a non-singular matrix using adjoint method. Noting that for non-singular matrix, the determinant of the matrix cannot be 0, and then we get the inverse. If the determinant is equal to 0, we cannot get the inverse of the matrix. Okay. Inverse of a 2 by 2 matrix. So we've learned in high school to find the inverse of 2 by 2 matrices. If A equal to A, B, C, D, so a 2 by 2 matrix, then A inverse is given by 1 over AD minus BC multiplied with, we exchange the position for A and D, and we put negative for C and B. So if you notice here, AD minus BC is the determinant of A. And then this part, the matrix here, is actually the adjoint of matrix A. Find the inverse of matrix A equal to 3, 1, 5, 4. So what we can do, we just have to apply in the formula. So what is the formula? We have to find the determinant. So how to find determinant? The formula is AD minus BC. So 3 multiplied by 4 is equal to 12, and 5 multiplied by 1 is equal to 5. So 12 minus 5 is equal to 7. And then we have to find the adjoint of matrix A. What we should do, we just have to exchange the position for A and D, and then put negative in front of C and B. So we have adjoint A equal to 4, negative 1, negative 5, 3. Okay, so this is the formula of A inverse, which is 1 over determinant of A adjoint A. So substitute the value of the determinant and the adjoint of A. What we need to do is the final answer must be in terms of matrices only. So we have to multiply the constant with each element. So the answer will be 4 over 7, negative 1 over 7, negative 5 over 7, 3 over 7. So this is the A inverse. So adjoint matrix. So actually, how to find the adjoint matrices? So for 2 by 2, we just have to exchange the AD and put the negative for B and C. But how about the 3 by 3 matrices? So if we let C is a matrix, be the cofactor matrix of A. So we have all the elements, all the cofactor for the elements in matrix A. So we can write down in the form of matrix. Then the adjoint of a matrix A is defined as the transpose of the cofactor. That is cofactor transpose. So if the origin cofactor is C of ij, we just have to rearrange the position of column and row. Transpose the Cij. So we have Cji. Remember, cofactor is equal to negative to the power of I plus j of the minor. So we just have the different sign only. So if we write down the cofactor in the form of matrices, so we have this formula: plus m11, negative m12, plus m13, and so on. So if we transpose this row will be the column. So let's do some example for 3 by 3 matrix. find the adjoint of matrix A. So what we need to do, we have to find the minor and the cofactor and then transpose the cofactor. So what is cofactor? Matrix of cofactor. This is the matrix cofactor. You can directly put the element. Okay, so for C11, what we need to do is to delete row 1 and column 1. So what's left is 2, 4, 1, 3. So find determinant of 2, 4, 1, 3. So we get 6 minus 4, which is equal to 2. And then so on, C12. So the position here is negative. So don't forget to put negative in front of the minor. So what is the minor? We delete the first row and second column. So what's left is 3, 4, 1, 3. So find the determinant of 3, 4, 1, 3. It will be equal to 9 minus 4, which is equal to negative 5. So we continue for C13. So we get 3, 2, 1, 1. So what is the cofactor? It will be 1. And then for C21, so it will be negative of 2, 3, 1, 3. So what is the answer? Will be 6 minus 3, so negative 3. So for the C22, so it's positive of 1, 3, 1, 3. So what is the result? It will be 0. And then C23, we continue. So we delete the second row and third column. So it will be 1, 2, 1, 1. So negative of 1, 2, 1, 1, it will be equal to 1. We continue with 3, 1. So it's a positive value there. And then we delete the third row and the first column. It will be 2, 3, 2, 4. So what is the result? It will be 8 minus 6, which is equal to 2. And then C32 will be negative of, we close the third row and second column, 1, 3, 3, 4, 3, 4. So what is the result? It's 5. And then the last one, C33, it will be positive there. And then we close the third row and third column. We have 1, 2, 3, 2. So what will we have as the result? Will be negative 4. So write down all of these elements. So what we have, adjoint is a cofactor transpose. So put down the cofactor, the element for the cofactor, and then transpose it. So we have the adjoint A equal to 2, negative 3, 2, negative 5, 0, 5, 1, 1, negative 4. Done. So let's do the example 3 where we want to find the adjoint P. So I won't show the answer. I won't show the working. I want you to try on your own. Can you try it? Okay. What is the solution for example 3? So the solution for example 3, we have the adjoint of P, the cofactor of P equal to 15, negative 1, negative 4, 0, 1, negative 1, negative 10, negative 1, and 6. So the adjoint of P, it will be the transpose of the cofactor, which is equal to negative 15, 0, negative 10, and then negative 1, 1, and negative 1, and then negative 4, negative 1, and 6. Okay, now we know how to find the adjoint. Now we want to find the inverse by using the adjoint method. So what is the formula for the inverse? Yes, it is the same as the 2 by 2 matrices, which is A inverse is equal to 1 over determinant of A multiplied with its adjoint. So this A inverse is not equal to 1 over A. Remember, we don't have division for matrices. So let's do some example. Example 4, to find the inverse of 3 by 3 matrix. So find the inverse of matrix B, 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. What is the solution? Remember, the first thing we have to find is the determinant. So you can use any of the row or any of the column. So for this one, for this example, we use the first column. So it will be positive 1, negative 3, and then positive 2. And then we just have to find the minor. The first one will be 2, 2, negative 1, 0. So what is the minor? it will be 2. And then for the second one, we get 0, 2, negative 2, 0. So what is the minor? It will be negative 4. So minus 4, it will be positive 4. And then the last one, we have these 4 elements. So 0, 2, negative 2, 1. So what is the minor? So it will be 4 also. So what is the determinant? It will be negative 2. Determinant of B equal to negative 2. So we continue in finding the adjoint method. So to find the adjoint method, remember we have to find the cofactor. So what is cofactor of B? It is yes, we have to find the minor for each element. So for the first row, we have positive, negative, positive, and then second row negative, positive, negative, third row positive, negative, positive, and then we put all the minor to find the minor by deleting the row and the column for the position. So what will we get for the first column or first element? So we get 2. The second element will be 4. Negative 4, negative will be 4 lah. And then, so this is negative 2 multiplied with 2. So 0 minus negative 2, so will be positive 4. So we have negative here, so will be negative 4. And then the third element will be 0 plus 2, so 4. And then this one will be 0 plus 2, so will be negative 2. And then this one is 0 plus 2 will be 4. Here, negative 1 plus 6, so will be 5. And then we have negative here, so negative 5. And then for here, 3 multiplied by 2, 6 minus 4 will be 2. 2 minus 0 will be 2. And then we have negative in front of it, so negative 2. And then the last one is 2 minus 0, so will be 2. So we have the cofactor already. Now we have to find the adjoint. So the cofactor B is equal to 2, negative 2, 2, 2, negative 4, 4, negative 2, 4, negative 5, 2, negative 2, 2. Okay, now what is adjoint? Adjoint is the transpose of cofactor. So this row will be the column. So this row will be the second column, and the third row will be the third column. So we have the adjoint. Now to find the inverse, we just have to substitute into the formula. So what is the formula? 1 over determinant multiplied with the adjoint of matrix A. So it will be inverse of B equal to negative 1 over 2, the determinant, 1 over determinant, and then multiply with the adjoint. So we have to multiply the constant with each of the element. So what we have as the results? Yes, we have negative 1, 1, negative 1, 2, negative 2, 1, negative 2, 5 over 2, and negative 1. So this is our inverse. Okay, as the same as transpose, determinant, inverse also have their properties. So the first one, if we have A inverse, then we inverse it again. So we have double inverse here. So we will get itself. And then A transpose, if we get the inverse, we try to get the inverse. It is the same as if we try to find the inverse of A, and then you transpose it. Okay? And then A multiplied by B, all inverse, is not equal to A inverse B inverse, but it is equal to B inverse multiplied with A inverse. So notice here the position is opposite. And the last one, determinant of A inverse is equivalent to 1 over determinant of A. Okay, so this is for the first part.